So now our next step in this problem will be to break all of our forces into components and to identify those x and y components. Our tension T points up and to the left, so it has an x component that points to the left and it has a y component that points straight up. So let's break our forces into components in a table. So the forces we have are the tension T, the weight of the sign pulling down, the weight of the post itself pulling down, and the force due to the bolt. And those forces will have x and y components where we take x to the right and y to be up. So let's do the x component of tension first. Our tension is at an angle, and it says that the angle is 30 degrees. So our x component is adjacent to our angle, so we'll use cosine. The x component points to the left, so it's going to be negative. So we have minus x component of tension equals minus t times cosine of theta, which is 30 degrees. Our y component is opposite that angle, so our y component will be found using sine. And it points up, so it's going to be positive. For the weight of the sign, so the sign pulls down with a force equal to its own weight. The weight does not have an x component. The y component points down, and it's the mass of the sign times gravity, 9.81. Likewise with the weight of the post, it doesn't have an x component. The y component is down, and the magnitude is mass of the post times gravity. And then the force of the bolt, we don't know much about the magnitudes of those forces, so let's call the x component force of the bolt in the x. We're going to assume that's positive, and the y component we'll call the force of the bolt in the y direction, and we're going to assume that one is positive. So there's all of our forces broken down into components. For the next step, we'll find all the torques using a torque method, and we'll put that in a table. Then we'll be ready to apply our Newton's second law.